solving quadratic equations using the quadratic formula. And really that middle question is what I'm going to spend most of my time on. I'm going to go fairly quickly on the other stuff because people don't usually have a problem with the quadratic formula itself. It's the end steps, the simplifying part, that's a problem generally. So quadratic formula is just what I did on the last completing the square video, because it's just the standard form with completing the square done to it. Somebody figured out if we completed the square once with standard form, we didn't ever have to do it again. So we do have to do it because, again, it helps us get into vertex form. But most of the time, given the choice, factor if you can, and if not, quad formula. So most people know this sung to the tune of Pop Goes the Weasel. I went trolling YouTube. I found various versions. One thing that I would say, if you're ever checking it out, make sure you remember it with the x equals in front, because that's reminding you that when we solve quadratic equations, we're looking for the x-intercept. So x equals is fairly important. I was kind of sad to see lots of versions that just started with negative b. All right, so all we have to do is take any quadratic equation like this one, and we've been talking about a, b, and c forever, and so a is 3, b is negative 12, c is 1, and plug those into the quadratic formula. So x equals negative, I tend to put parentheses, plus or minus I tend to write it like that first, because that's going to help me not make mistakes in was I supposed to add or multiply, etc. And also, I know that this negative often gets me in trouble, so I put that parentheses there to remind me if I have a negative b like I do now, it's going to be negative negative. So the next step down, we're going to have a positive 12. So x equals negative b plus or minus square root b squared minus 4ac over 2a. And it's BBACA, and that's really how I remember it. All right, so now we just have to simplify. Again, plugging in, not a problem. One of the big mistakes people make is they forget that negative there. And the next couple steps people don't generally have a problem with. Usually pretty good with this, usually pretty good with this, usually pretty good with this. Usually remember pretty well that we're going to do the tree to simplify. I'm not going to show the tree. I'm just going to write the simplified version next. We've got x equals 12 plus or minus 2 root 33 over 6. And most of the problems come from here down. This is the part that makes sure you understand why we're doing what we're doing, because people tend to mess up. So what we need to do in order to simplify this any further is, if we're going to simplify anything, this, it's a little dark, this, and this all have to have a common factor. If they don't, we're not going to simplify. So what do 12, 2, and 6, what's their greatest common factor? Their greatest common factor is 2. So I'm going to pull a 2 out on the top and a 2 out on the bottom. Again, if I was just doing this in order to graph it, and if I was using a calculator, I could plug that whole thing into the calculator and get a decimal value. But if we want to write it, simplified, then we're going to factor something out on the top and bottom, and it has to be the same thing, because eventually we're going to get rid of it. So let me double check. 2 times 6 gave me my 12. 2 times 1, because there's an invisible 1 in there, gave me that 2 that's now gone, and 2 times 3 gave me 6. So the simplified version, because we can divide top and bottom by 2, simplified version is 6 plus or minus square root of 33 over 3. And again, I could get a decimal for that. I could plot that on the x-axis. Those are x-intercepts, aka roots, aka zeros, aka solutions, right? And so if I wanted to graph those, I could. Do x squared plus 3x equals 1. So that's not in standard form. First thing we have to do is get it into standard form. We've got x squared plus 3x minus 1 equals 0. A is 1, B is 3, C is negative 1. Like I said, the next steps are not the big issue, so I'm going to jump ahead. So that one, there's no work to be done. Double check. 3 and 2 and 1 have no common factors. There's nothing to be simplified there, so that one just stays as is. Okay, you should be trying these on your own by this point. Try to work it out. Again, I'm going to jump ahead, and really I'm going to focus on just practicing with you or demonstrating to you the simplifying part. It's nothing new, it's just old algebra rules, but that's what people struggle the most with. Now here I have a negative square root. So remember, the first thing we're going to have to do is take out an I, and then we still have to simplify the square root of 96. I'm not saying you have to do it separately, I just like to call it to your attention that way. So I've already done the factor tree deal on the square root of 96, and it's 4 root 6, so it's going to be 4i root 6. Now this time again, this and this and this have something in common. So I can simplify dividing a 2 out of everything. So I end up with negative 1 plus or minus 2i root 6 over 5, because those guys cross out. So I'll just write it one last time real big. Negative 1 plus or minus 2i root 6 over 5. Up till now, all the ones that I've done could not have been factored because they had radicals in their answer. So I knew I was not going down the wrong path when I used quad formula. Could use completing the square on some of them, but this one, it's one I could factor, and it's a special one. I hope you could factor it like in 2 seconds. But I'm going to use quad formula just in case you use quad formula on some of these that are factorable. You don't freak out when they simplify the way they do. So I'm going to do the work fast. So what's special about this one? We're going to end up with a 0 under the square root symbol. Well, what's the square root of 0? Square root of 0 is 0. So this is a special one in that it's only got one answer. Just 1/3. That's it. It's a perfect square trinomial. Remember how those sit and their x-intercept is their vertex? This is one where it sits on the y-axis like that. So it's just got the one root, one solution, 1, 0, one x-intercept. And then I'll do one that's just factorable, but it's got 2 roots, just so you see that. just a plain old normal kind of quadratic here. And so I'll do this fast. Okay, so the square root of 169 is 13. So now I don't have any more radicals. This shows me it would have been factorable. I'm going to get integer roots. Sorry, I'm going to get rational roots. They're not necessarily integers. And so from here, when you have that plus and minus and you have an integer after it, we're going to split it into two, whether it has a denominator or not. This one happens that it'll have a denominator. But we're going to split it into its two separate answers. So we have negative 7 plus 13 over 4, and we also have negative 7 minus 13 over 4. And the one on the right seems a little simpler. We'll do that one first. Negative 20 over 4. So x equals negative 5. There's an integer root. This one we get 6 over 4, so not an integer root, but we can simplify it to 3/2. Or actually, let's make it, well, we could make it 1.5 or 1.5, but this is fine for our purposes. So we could have factored this. It would have been factorable. As long as we don't have a radical in our answer, we could have factored it. But it works just as easily to do this quadratic formula. A recap question that I didn't write down was, when do you use the quadratic formula? I just want you to know it will always work on any quadratic equation. It should be your default if you're not sure what to do. You have to know how to factor, you have to know how to take square roots, you have to know how to complete the square. But if you freeze up and it's multiple choice and you don't know when it says solve, then use the quadratic formula.